When looking at the area of parallelograms, a good starting place is to ask, well, what are they? What are parallelograms? So, parallelograms are four-sided shapes with opposite sides parallel. Okay? Well, basically that's a fancy way of saying it could be a square. Okay? So, this square is an example of a parallelogram. However, usually when you see a parallelogram, a lot of us think of the two horizontal lines that run parallel, but then we also think of the slant and how those lines are connected like that. Okay? So this is also an example of a parallelogram, albeit not exactly perfect parallelogram. It is one, nonetheless, for what we're doing. Okay? So when we are trying to figure out the area of a parallelogram, we need to remember that the area, or A, represents the amount of space inside of the figure. So if you imagine yourself coloring, okay, you would come and you would color in this entire shape. And I'm not obviously going to take the time to get every nook and corner, but you get the idea. When you're coloring in the whole thing, that whole amount inside of the shape is our area. And of course, like always, there's a formula for determining the area of a parallelogram. Now, when we're looking at squares, we know that the area equals length times width. Then when we were studying triangles, we knew that the formula is of area of a triangle is 1/2 times base times height. So what happened was when we were looking at triangles, we had to create 90-degree angles in order to be able to find the proper height for our triangles. Okay? And remember, the height is from your base of the triangle up to the topmost corner of the triangle. Okay? That is the height. The distance from the base to the topmost point of your triangle. So when we are looking at parallelograms, we're going to use the same formula, but in a slight variation, as we are with the square. Okay, so when we're looking for the area of a parallelogram, we can use the formula of just base times height. Because what happens is we still get a base like we normally would with a square. However, since this parallelogram slants, these slanted lines are actually not the same size as the height of the entire figure. Okay? When we look at the height of a parallelogram, we are going to revert to what we did similarly for triangles. And we have to look at our base. Okay, so I'm going to outline that in green. Let's say that's our base. Then from our base, we extend all the way up to the topmost part of the figure. And in this case, it's right about here. Okay, so that part there that I just dotted in green is actually the height of our parallelogram. Okay, so the area of a parallelogram is to take the base, whatever number that is, and you multiply that by the height. And the most important thing to remember is with parallelograms, a lot of times you're going to have to visualize that 90-degree angle, and you're going to have to create that 90-degree angle in order to find the height. So we will do a lot more examples in class of this, but we are going to sign off for now. And make sure you have this formula of a parallelogram ready to go in class so we can continue on with the studies.